are the inverses of one another. And we said that the function inverse of one another, if and only if we have, for example, y, let's call it equal to f of x, and f of x, let's say the second one, let's call it y2, and call it g of x. So we said the function f operating on the result of g of x, if this is equal to x, then f of x is inverse of g of x. What does it mean? That means f of x, or f prime of x, equal to g of x. This means the inverse of f of x, we call it g of x. So let's try to prove that these two are inverses of one another using these rules. We said we will set one of them, let's say this is x squared, and g is the square root of x. Okay, so we said we're going to go ahead and apply f g of x. Okay, and to do this, first we will apply the inside. The inside g of x is equal to how much? Square root of x. G of anything is a square root of that thing. Okay, so this will be f, and instead of this, square root of x. And then we have to operate f now on square root of x. If anything in it is any parameter, you send it inside f, it's going to be squared. So inside f now I have square root of x, so this is going to be square root of x all squared, which is equal to x. So that proves that f of x is the inverse of g of x. We've done this last class, right?
No, we didn't, Doctor.
Okay, let's just take a look at a couple of functions. Let's say f of x equal to 3x plus 4. What is the inverse of this function? Anytime we have something like this, we put y equal to f of x. So y equal to 3x plus 4. And then what we do is we replace x by y and y by x. So this will be x equal to 3y plus 4. And then we solve for y. We solve for y. We have 3y plus x. So to solve for y, we will have x minus 4 equal to 3y. So y is equal to what? X minus 4 divided by 3, right? So this is the inverse. So this function is the inverse of this function. Inverse. We can prove that by taking an example. So let's suppose that we have f g of x. Okay, where we will call this g of x. And that one is f of x. So f of g of x, that means we will first find what g does to this parameter. So the parameter of g ends up becoming something like this. So we'll say f of x minus 4 divided by 3. Okay, so this is f of this. But then we know that the function f of x does this. That means whatever is the parameter, we multiply the parameter by 3 and add 4. So let's go ahead and do that. So multiply the parameter. We know the parameter is x minus 4 divided by 3. We multiply it by 3 and then we add 4 to it. 3 goes with the 3, and then we will have what? X minus 4 plus 4 equal to X. So that proves that this is the inverse, right? Let's give another example. Let's suppose that I have Y equal to cosine, let us say, of 6X. Okay, so if that is plus 3, whatever. Okay, if we want to find the inverse, how are we going to do it? Change every X into Y, change every Y into X. So we will change Y into X, and we'll go and change X into Y plus 4. Now we have to solve for what? We have to solve for Y. And to solve for Y, it's going to be a little bit tricky, but we could just move one at a time. So we'll put the 4 on this side, and on the other side it will be what? Cosine of 6Y. We want to take this 6Y outside and then divide by 6. So to do that, we will say X minus 4 equals to, I'm going to go ahead and put cosine inverse. Okay, let me put cosine inverse over here. I'm going to take cosine inverse on the left-hand side, cosine inverse of the left-hand side, X minus 4 equals to cosine inverse of cosine of 6Y. Okay, so on the right-hand side, cosine inverse of cosine, that's going to cancel cosine, right? So I will have 6Y. And this will remain as cosine inverse of X minus 4. Right? Now we have to divide by 6, right? So I can say Y equals to cosine inverse X minus 4 divided by 6. Okay, so that is the inverse. You can verify it by doing the same test that we've been doing. Okay, now let me ask you this question. Assuming that I have a table, and the table has the values of X and Y. Let's suppose that this is X and this is the Y. Okay, so 1, 2, 3, 4, and 5. Okay, let's say A, B, C, D, and E. Okay, now what is the inverse of this function? To do the inverse of this function, all you need to do is to make X equal to Y and Y equal to X. So I'm just going to make this one as X and make this one as Y. Okay, and to make it easy for you to understand it, let me just put numbers. Let's say 8, 9, 6, 2, and 7. Okay, so if this is X axis, I'm sorry, this is X and this is the Y. Okay, so this function is f of X. If we swap them, we put Y equal to X and X equal to Y, let's call this G of X. So G of X is the inverse of f of X, and f of X is the inverse of G of X. You can go ahead and figure that out, and you will see that it works really well. Okay. Any question? Okay, if there are no questions, let's get going. The logarithmic function with the base a, y equal log to the base a of x, is the inverse of the base a exponential function. So y equal to a to the power x. Okay, that means a to the power x is the inverse of log ax. Okay, a to the power x is the inverse of log ax. I want you to help me with finding or proving this one. Any suggestion as far as proving this one?
Yes.
Give me a suggestion.
By graph.
Huh?
By graph. أنت الرسم يعني.
Okay, let's see. We could do it by graph, but let's do it by, the same rule, g of x. Okay, so let's say g of f of x. Okay, so we want g of f of x. To work g of f of x, let us say f of x is equal to a to the x. So call this one f of x. And we call this one what? G of x, right? So g of f of x. G of f of x will be equal to what? Will be equal to g of what? A to the power x, right? Because it's g of f of x, right? A to the power x. And then g of anything is nothing but the log to the base a of that thing, of a to the power x, right? Hi, Shabab.
Yes. Right.
Now we have log of a to the power x. I can put the x to the left, right? And put it down. And this will be log of what? A, log of a, log a of a. What is the value of log a of a?
I think 1.
Equal to 1, right?
1.
So this is equal to x. Doesn't it show that this is the case? Because we said to prove that f is a function that has an inverse g, okay? We said you have to apply g on f of x, and if the result is x, then they are inverses of one another. So everybody's comfortable now? You can apply the rule to
Victor,
find.
is it the inverse or not?
Huh? Yeah.
Are they inverse of each other?
Look, we said if f of g of x equal to x, then f, okay,
Yes.
inverse of x is equal to g of x. That means they are inverses of one another. It doesn't matter if you do this f of then g. You could have g and then f of x, and it should still work fine. Okay.
Okay.
It will give you x anytime.
So it's inverse.
Yes, it is inverse. Yani inverse.
Okay.
Let's suppose that you have a value. Okay. One function multiplied by 2 and the other function divided by 2. What would the result be? You have a function f of x. Let's say f of x equal to x.
Yes.
Okay, one function multiplied by 2, the other function divided by 2. You get x back, right?
Yes.
So that's why. So anytime you have a function and its inverse, and if the function operating on the output of the inverse gives you x, that means the function and its inverse are correct.
Okay.
Okay. So that much about this one. If it is clear, we will get going then. Now, here are examples. This is an example. Instead of y equal to a to the power x, we have y is equal to 2 to the power x. So we're taking some numbers. And instead of y equal log to the base 2, log to the base a of x, we have y log to the base 2 of x. And it's very clear that these two are inverses of one another. You can prove that. Let's take an example of these. Let us say, for example, 2 to the power y equal to 2 to the power 3. Okay. And I'm going to put over here y1, let's say y2 equal to log to the base 2 of 8. Okay. Are they inverses of one another? They have to be, right? They have to
Yes.
be. We just proved that they are inverses of one another, right?
Yes, doctor.
Yeah, so you could just go ahead and apply the rule. If you apply the rule, you're going to get it, right? Do we have to do it or it's easy? If it is easy, we keep going. If you want us to do it, we'll do it. Shabab, g of f of x. Just do g of f of x. You can call this one f of x and you can call this one g. You can call this one f of x and you can call this g of x. Okay, and then you just do the test g of f of x or f of g of x and you will end up getting what? Getting the value of what? X, right? You're going to get x out. So since you're going to get x out, they are the inverses of one another. One thing that I wanted to show is that, let me just go back on very quickly on the previous one. Not this one, maybe here. Look at this one. Anytime you have functions crossing each other, and these functions are inverses of one another, that means they have a one point in common. That point is that this probably equal to 1, this is equal to 1. So 1 is the only one that is common between both of them, right? Because y equal to, put x equal to 1, and y equal to, put x equal to 1. In both cases, what is the answer? Y of 1 square equal to 1. Y of a square root of 1 equal to 1, right? So that's why they have this across, okay? And if you use y equal to x, this as a mirror, then you can see that you will have what? Symmetry, right? So the two functions are symmetric about y equal to x. So these are all the values where y is equal to x, this line. Okay? So
Okay.
let's go to the other function. These functions, they're not crossing each other. They don't cross. Not all functions cross each other. So these functions, you can see that they have y equal to x as a mirror, but then there are a few things. Like for example, when you have 1 on this function, you have 1 on this function. When you have 2 on this function, okay? See, you have to go all the way up, okay? And then you have 2 on this, and so on. You see the mirror image? Everybody see the mirror image?
Yes.
Okay, so that is this function. Let's take a look at. This is similar to this one, but the base 2 and the base over here is e. Okay, and there is something that's of interest here. This is y equal e to the x, y equal to ln x. So these two are inverses of one another, right? Let's just go ahead and prove it. Okay, so call this one f of x, and call this one g of x, right? We said, how can we prove that these two are inverses of one another? If we take f of g of x and prove that this equal to what? Prove that this is equal to what? X. If it's equal to x, then they are what? They are inverses of one another, right?
Yes.
Okay. So f, we have f what is g of x? What will g do to its parameter? It will take ln, right?
Yes.
Now what will f do to its parameter? It takes it
It will
as
take it.
the
Yes.
power, right? So this will be what? E to the ln, right? X, right? E and ln, they cancel each other. You get what? You get x. Okay? E and ln will cancel each other. You get x. Right? Everybody?
تقدر تشرح
Question?
بالتفصيل يا دكتور هذا أكثر الاختصار هذا اللي فوق تقدر تشرحه بالتفصيل أكثر.
Okay, let me just remind you of the ones that we did, and I want you to try to do it in the same manner. Okay, I'm going to go ahead and repeat. Remember when we talked about g of f of x? Because I know that you guys understood this. G of f of x, okay? And we said that f of x is equal to a to the power x. So this is equal to g of a to the power x, right? G of a to the power x, right? If f of x equal to a to the power x. So g of f of x will be g of a to the power x, right? Now, g of x will take the log of whatever is inside. So let's say g of x equal to log to the base a of x. Okay. Log to the base a of x. Okay, so this is going to be equal to what? Equal to log to the base a of what? X to the power a to the power x, sorry. Right? Anytime we have log of something, we have to take this thing to the left-hand side. So this will be equal to x log to the base a of a. Log to the base a of a is equal to 1, right? So we have x, right? You can do it in the same manner. You can do this one in the same manner. You want to do it in the same manner? Either way is fine. Okay? So just let's follow it one by one. Okay? We said f of x equal to a to the x. So here y equal to e to the x. Instead of a to the x, e to the x. So this is our f of x. And we said g of x equal to log to the base a of x. But here we have ln to the base e of x. So we'll just have, okay, pretty much the same, right? So let's just follow it step by step. We said we want to see g of f of x, right? G of f of x here, we said is equal to g of a to the x. Over here it will be what? Equal to g of what? E to the x, right? Yes?
Yes, دكتور.
Okay. And now the second step, g of a to the x, we said g, its parameter will be the parameter of log. That means g will apply log to its parameter. So log to the base a, you have to apply ln, okay, to the base e. So this will be equal to ln to the base e of e to the x, right? Yes? Now, anytime you have ln and then you have e to a power, you can take the power to the left. So that will be x, and then it will be ln e of e. Ln e of e is equal to 1. So that will be equal to x, right? Is it clear?
Clear.
Clear? Good, good. If it's clear, let's get going then. Now, ln x equal to y. Ln x equal to y, equivalent to saying e to the y equal to x. How do we prove this? I want to take this one and prove this, and then take this one and prove this. Okay, so let's go one at a time. So from this one, I want to get this one. Okay, you can say I have ln x equal to y. I want to get this one. So all I need to do is what? I need to raise both of them as powers of what? Of e. So this is e to the ln x, and this is e to the y, is the power y, right? So this is e to the ln e of x, right? Now, we said for the ln, anytime we have ln like this, we have to take the x to the left of ln, right? So we'll have e to the x, and then ln e of e. We take the e right there, ln e. Okay, this is ln e of x.
Doctor,
Yes.
how ln e power x in the left? This is correct.
Which one?
In the left, ln.
This one? Which one? Which one? This one? This one?
Yes.
Yeah. This one ln to the base e of x. See, all what we did is, look, what do we have over here? This is ln to the base e of x, right? We want to show that it's equal to what? Y. So what we said we're supposed to do, just raise this one to the power, make this one as the power of e. And since you did that, is make also this one as a power of e. Okay, look, we're trying to get what? To get the left-hand side. Already we got the left-hand side here, e to the power y, right? So we have to justify this one. Okay, e to the power ln e x, okay? E to the power e ln x, okay? This is something like this. Let me just expand it. E to the power x. Okay, so ln e to the power x, we can take the x to the left-hand side, right? معي شباب؟ معي؟
إيه معك يا دكتور.
واضحة؟ هذه ln e. Let's just put it ln because e is confusing there. E is confusing. You know, ln that means ln e. That means that the base here is e. Ln e of x, right? And when we have e and ln, they cancel each other, right? When we have
Yes,
e and
It will be equal x.
so this will be equal to x. Yes, you're right. Okay, so this is equal to x. That means x is equal to e to the power y, which is this. E to the power y is equal to x. So we started from this one. We got that one. If anybody not following, I will try to do it using the log and then get it back. Okay. You want me to use it, the log base a?
We get it, we get it.
You got it? Okay, good, good. Okay. So now let's go from this side to this side. To go from the side of e to the power y equal to x, we want ln, you can see this is ln x. That means I have to take ln of both sides. So I have to take ln of this one, I have to take ln of this one. So ln of this one, he gave me the left-hand side. I have to prove that ln e e of e to the power y. I have to prove that this is equal to what? I have to prove that this is equal to what? Equal to y, right? Because we're looking from this one, going from this one to this one, right? Going from this to this one. And this is our, this is this one, and this is this x. Okay, to go from this to this, we said we have to take ln, because there is here ln x and this is x. So take ln of both sides. If I take ln of the x side, it will have ln x, which is this part. Okay, now we have ln base e of e to the y. Okay, ln base e of e to the y. Anytime we have this, we can take what? The y to the left. So if we take the y to the left, we have what? Ln e, right? Ln e is equal to what? Equal to 1, right? So this will give us 1, y, right? So y equal to ln x, which is this. We move from this to this, y equal to ln x. Okay? وضحت يا شباب؟
وضحت.
Okay. This one is clear. It says in particular, if we set x equal to e, we get this. Put x equal to e. Okay, so over here you get what? Left hand side, x equal to e. It will give you what? Ln to the base e of e, right? Because x equal to e, ln to the base e of e, right? Equal to y. Okay, and this is equivalent to saying we put instead of x, e, right? So e to the y equals to e. Okay? All I did is I just went ahead and replaced every x by e in this. So this becomes ln base e of e. Instead of x, I put e. And then this is y, it remains as it is. And the other side, e to the power y remains as it is, equals to x. We put it equal to e. Okay? Now let's take a look at the left-hand side. Ln e to the power e is equal to 1, right? Ln e of e equal to 1, right? Shabab, ln e of e is equal to 1, right?
Yeah.
So this is equal to y. That means y, right? Let's go to the other side. The other side, I have what? I have e to the y, right?
Right.
E to the y. But e to the y is equal to what?
E.
1.
Look, all what we need to do is we need to show that ln e is equal to 1. Okay? All we want is we want to show that ln e equal to 1. On the left hand side, ln e of e, right?
It's
Uh-huh.
ln e of the power e. It should without e.
Huh?
Ln e of the power e. It should without e in the down.
You're talking about this one?
Yes.
This is the base. You know, the book doesn't write the base. This is the base. Ln e of e, ln a of a, log a of a, log 2 of 2, log 9 of 9. They're all will give you a.
One already has e. Like
Already has. No, this is ln e of e. They said put x equal to e. Put x equal to e. That means instead of x here, I'm going to replace it with e.
Okay.
Okay. So I replace it with E. I have ln E of E, and this is going to give me 1. Right? So 1 is equal to Y. Right? And then on the other side, I have what? E to the Y equals to E, because they told me also to change X into E. So E to the Y equal to E. So now I have E to the Y equal to E, and I want to get to the ln E of E to be equal to 1. That means I have to prove that Y equal to 1. If E to the Y equal to E here, what does that tell you about Y? Y is equal to how much?
1.
That's it. If Y is equal to 1, that's it. Okay. So Y is equal to 1. That means ln E of E is equal to 1. Which is this?
I have a question.
Huh?
1A is equal 1.
Yeah, let's just take this E. This E is,
E of the power A.
yeah, let's eliminate this. It's going to confuse you. But anyway, you have to remember ln E is equal to 1. Ln E is equal to 1. Okay? So this is ln E, it will be equal to 1. This is Y. And on the right-hand side, we have E to the Y equal to E. Right? Because E to the Y equal to X, but they told us change X into E. Okay, so we put E to the Y equal to E. Right? So now ln E is equal to 1. This is equal to Y. Okay, on the other side, it will give us E to the Y equals to E, right? Since we have E to the Y equals to E, that means Y must be equal to 1, right? Because this is E to the power 1. So E to the Y means Y equal to 1. So if Y equal to 1, okay, which we already have on this hand side, then we can just replace this by 1 here. This Y, we replace it by 1. So we'll have ln E equal to 1. Correct?
Correct.
Okay. And this is just showing, this is just showing that this here, these two here are the same. E meaning E to the 1. Okay? Shall we move? Don't hesitate. I will repeat. If anybody not following, please don't hesitate. Ask me, I will repeat. Okay, good. Here are the rules. These rules are easy. Like if you have ln of a constant multiplied by a variable, it doesn't matter, equal to ln of the constant plus ln of the variable. Ln of the product is the sum of the lns of the two. Ln of the ratio of 2 is the difference between the lns of the numerator and the denominator. Ln of 1 over x equal to minus ln x. How do you prove this one? Ln of 1 over x is similar as ln what? Of x to the minus 1, right? But ln of x to any value, ln of x to any value, you can take that x down, right? The value. X to the power -1, you can take -1, and then ln x, right? So -1 ln x is the answer, right? And then we have ln x to the power r. We just said the same thing. So you can take r to the left, that will give you r ln x. Okay? Anybody? Okay. Now, we have some properties, inverse properties of a to the x and log a x. The base a equal to a log base a of x equal to x. This is very important, so I want you to closely watch. Okay, one more time. A to the log a of x equal to x. Why? Because anytime log like this, the x will be the survivor, and this will be equal to 1. So that will be equal to x. Okay, so that's equal to x. And then log a of a to the x equal to x. I think this is easy, right? How can you
Yes,
prove
professor.
this?
Yes.
Take x to the left, and then log a of a is equal to 1. That's it. Right?
Right.
Okay, what about this one? How are we going to prove this one? Huh? How are we going to prove this one? I want some hints from you.
Yes, Dr.
Uh-huh.
to على شكل
ها؟
S
Huh?
change this to exponential.
I could hardly hear you.
The power X.
You want to do what? We have a log to the base a of x equal to x. How can we prove that? Hi, Shabab.
Doctor,
Remember the rule that we were talking about all the lecture? F of g of x equal to x. That means they are inverses of one another, right? Didn't we just now say that a raised to exponent and log of that exponent are inverses of one another? I want you to help me in doing this. We want to prove this one. This one, we said it's easy. All you got to do is just put this one on the side. On the side and log to the base a of a is equal to 1. So you get x times 1 equal to x. Okay? So if that is the case, how about this one? How do we prove? Huh?
May I insert
Go ahead.
نضيف لجرسهم
Huh?
طرفين نضيف لجرسهم حق الطرفين
You want to take what?
لجرسهم
Oh,
both sides.
log of both sides.
Yes.
But if you take a log of this and a log of this is going to complicate it. You don't want to complicate it. You want to just go ahead and prove that this is equal to x. That's all. Just like the way we prove this equal to x, you want to prove this equal to x. Any ideas?
Can I answer?
Yeah, go ahead.
I think that a is the inverse of log a, so they go. They can cancel each other. Then x is going to be x.
Right. That's the answer to it. That's the answer to it. Anytime you have a log to the base a, where a to this exponent, so you have like f of x, f of g of x. This is f of g of x. So g of x here is what? G of x here is log to the base a of x, right? That's g of x. And then you have to have x, f of x. We said f of anything is equal to a to that thing, right? ها؟ معي يا شباب؟ شباب لو ما معي برجع بعيدها.
Yes,
أعيدها مرة ثانية؟ ها؟ Anytime you have x on any side, this one was easy, but this one we have to do it f of g of x. Okay, so what is our g of x? Our g of x is log to the base a of x. This is our g of x. Okay, this is our g of x. And our f of x is a to the x. Okay, so we have f of log to the base a of x. This is just like saying f of g of x, because g of x is equal to this, right? But f is equal to what? F of x equal to a raised to the power x. F of anything equal to a raised to the power that thing. So we can conclude that f of log to the base a of x is equal to what? A to the log a of x. Isn't it what we want? Huh? Hi, Shabab.
Yes. Yes.
Is it difficult? Just remember the rule, ya Shabab. Just remember the rule. Remembering the rule is going to help you a lot. The rule is just f operating on g of x. And then you just put everything and it should go straight forward. Shall we do this also? It's the same concept, right? Instead of log to the base a of x, ln e of x. The rest is the same. Everything is the same, right? Should we do it? That's enough.
enough.
Okay, now let's take a look at the next one. Anybody said, anybody need help over here, or it's clear?
It's all clear.
Okay.
Clear.
Every exponential function is the power of the natural exponential function. One more time. Every exponential function. This is the exponential function. Right? It says what? It's the power of the natural exponential function. Okay? The natural E. Okay? So a to the x should be what? Yes, Shabab. We said every exponential function, which is in red here, this one, okay, is a power of the natural exponential function. Okay, it's the power of the natural exponential function. That means it's equal to e and then x ln a. So we can say a to the power x equals to e ln a to the power x. Right? This is the natural exponential function. Ln of a to the power 6 as the exponent of e. Okay, so a to the x equal to what? Equal to this, and this could be rewritten as what? e to the x ln a, which is this one, right?
Yes, doctor.
Okay, so this tells us that what? A to the power x is similar to e to the power x raised to the power ln a. Okay,
Okay.
can you follow? I mean, are you following? We said a to the power x is same as e to the power x raise this to the power what? Ln a, right?
Right.
Okay, now you can rewrite this one to get this result. Okay, which is what? Which is e, this to the power this is the multiplication of the two, right? So multiplication of the two will give you x ln a, right?
Right.
Okay. Now a to the x equal to e to the kx, or k equal to ln a. Okay. Let's take a look at this one. A to the power x equals to e kx. Okay. E kx for k equal to ln a. So that means we can rewrite it as what? Equal to e to ln x, right? K is equal to ln a. So ln a times x, right? E to the ln a times x. Shabab, is this clear? Shabab, is it clear? The only difference between this one and this a to the x is the same as e to the x raised to the power ln a. Okay, e to the x raised to the power ln a is just e to the x, a to the x ln a. This one, e to the x ln a. So ln a is going to be a to the x. Ln a is equal to a to the x. يا شباب
Yes, teacher.
معي يا شباب؟
Yes.
لا ما معي، أنا قلت كلام غلط وما في حدا يصلحني. أنا قلت ln a equal to a to the x. Ln a is not equal to a to the x. Okay? A to the x is equal to e multiplied by constant and x. That constant must be equal to ln a. That's why this is valid only when k is equal to ln a. We will see this when we do the ln going from log to ln. Okay? Now, here is going from log to ln. Log to the base a of x equal to ln x over ln a. That means you can just change from any base to the natural base. Assuming, of course, over here a should be greater than 0 and should not be equal to 1, because log to the base a in that case will be equal to the natural log, which is not the case. That's why this exclusion. But this rule you have to remember. Okay, log A of X equal to log X after ln X divided by ln A. So you want to, oops, sorry. Let me hook up this thing. يا شباب انا طولت عليكم ولا عادي؟
على عادي يا دكتور.
يعني مستعدين كمان نمشي شوي؟
ما في مشكلة.
ايه بارك الله فيكم. Okay, let's get going then. Here is the inverses of functions. Okay. Now let's go back to the function itself.
دكتور دكتور
Yes.
how many minutes will it take? Because
This
I have
one?
work.
Oh, you have work?
Because I have work after. Yeah, I work in a place. If you're not gonna take more than 15 minutes, I can say no problem.
More than what?
15 minutes
15 minutes?
extra.
Inshallah, let's just
15.
do 15 minutes. 15 minutes. Just remind me
Okay.
after 15 minutes.
Okay.
Okay. Let's go ahead and take a look at the x-axis and try to put the sine curve. The x-axis and this is the y-axis. And we want to do the sine curve. So the sine curve will be something like this. And on this side, it will be something like this. I'm just gonna cut it over here. Okay. Now, if this is 0, what do you think this one is? Huh? If this is 0, this is pi over 2, right? Because sine 1 is pi over 2, right?
Right.
Sine pi over 2 is 1, right? So if this is pi over 2, what do you think this is? Pi. Right? Very good. And if this is pi, this must be what?
minus pi over 2.
Minus 1. But if this is pi, this is pi over 2, okay? Then you add to pi over
3 pi over 2.
Yes, excellent. 3 pi over 2. Very good. And of course, it's negative, right? Now, basically, we're looking for 1 and minus 1, right? It alternate 1 and minus 1, 1 and minus 1, right?
Yeah.
Let's take a look at the domain of sine x. So this is sine x. The domain is what? From
all real numbers.
minus infinity to infinity.
minus infinity to infinity. Very good. This is a domain minus infinity to infinity. What about the range?
minus 1 to 1.
Minus 1 and 1. Very good.
With
Okay.
the minus 1, am I right? With the minus 1, it is the close.
The minus?
Minus 1 with the range.
Yeah, the range is minor. Where? The range is normally the value of the function on the y direction. So the function, it has what? 1 as the highest and -1 as the lowest. If you take a look at the sine of negative pi by 2 is equal to -1. The sine of 3 pi by 2 is equal to -1. Okay. So this is the domain, but this domain is, includes everything. We don't want to go that far. All what we have to do is we will say, okay, the local domain is, we can just speak from pi over 2. We can just take one, see, from negative pi over 2 to positive pi over 2. That is 1 pi. So this is 1 period, right? So we were taking from negative pi over 2 to positive pi over 2. Okay, Shabab?
Okay, okay.
So we're taking the domain that way. We don't want to go from infinity, negative infinity to infinity. We just want to go 1 period. Okay, so from negative pi over 2 to pi over 2. Now, we said if we want the inverse of any function, we have to make what? We have to make it is domain, its range, and its range, its domain, right? We express this by, if I have x and y here, I want it is inverse. The inverse will be what? I have to make this one. I have to make this one y, make this one x, right? Reverse them. So if I make the domain from negative pi over 2 to positive pi over 2, if I made it, instead of the domain, I made it the range, then you can see from negative pi over 2 to positive pi over 2, right? Now, I want to go to the domain of this. So the domain of this is range of the original one. Range of original one is -1 and 1. So this will become the domain of the new one. So it's -1 and 1, right? So you're going to have to connect, okay, negative pi over 2 and 1, this point, and positive pi over 2 and 1. So you have to connect them. You have to go through the origin because this is common between both, right? So you have to go to the origin and then you have to get out, right? And this is just dotted line to show you that this is the completion, okay? Is this clear? The inverse. You just look at the domain, okay? And once you look at the domain, make the domain the range and the range domain, that's it. So over here, we picked as representatives of the domain minus pi over 2 to pi over 2. And from that, we also deduce the range to be -1 and 1. And then we just swap them. We made the domain range and the range domain. And if you do so, you can see that this is what? This is the domain. You know, outside this, we don't care about it. That's why you have dots above pi over 2 and dots below negative pi over 2. Okay, so this is the domain and its range. Okay?
Okay.
Okay.
Let's see. Here are just domains and ranges for different functions, right? This is a sine. You can see domain of the sine. right? Domain of the sine, and this is the range of the sine. Okay. So this is cosine, the domain of the cosine and the range of the cosine, and so on. That's a tangent. Okay, I don't want to go through this because it's going to take longer time. So I think we will best stop right here. We have a couple of slides, and after that we go to chapter 3. We're going to have the worksheet. I will update the worksheet and send it to you. Any question? Ya Shabab?
No, thank you, Doctor.
Unfortunately, I tried my best to get this course to be online, but I failed big time. I mean, they said no. I think this is something that's coming from the Ministry of Education, especially for the second year students. They must attend classes face to face, except if the classes are too large, and our classes are too large. So we cannot follow in that exception. But we will do my best, inshallah. The boards are really not encouraging. The equipment is not encouraging, but we have to do what we have to do. That's it for today, and thank you. Thank you very much for your patience. Actually, I felt very sick, that's why. And I am still today, I'm not feeling well, but I had to do what I had to do. You realize the difference in my noise, right? In my voice, right?
Yes,
Yes.
Doctor.
Yeah, so just pray for me.
I hope you get well soon, sir.
Barakallahu fikum, jazakumullahu khairan. Inshallah, inshallah, I will go ahead and send you W2. I'm going to add some problems to it and send it to you. And we'll see you inshallah next week. Barakallahu fikum.
Wait, sir, I have a question.
Atfaddal.
You said you were going to add questions to worksheet 2?
I'm going to add some questions to worksheet 2, yes.
But I already submitted worksheet 2 today.
Huh?
I already submitted worksheet 2 today.
Okay, that's good.
Can I submit again after you
no,
have the questions?
no problem. The idea is just to let you guys do the work, that's all. Yeah. I don't mind at all keeping it open. Yani. I'll keep it open.
Okay.
I trust that you're going to do the job. That's okay.
Thank you.
دكتور وركشيت 1 انا اللي كلمتك انها تقفلت وانا ما قدرت ادخلها.
Oh,
إلى الآن
don't
ما
worry.
فتحت لي.
Don't worry about it. Don't worry about it. Don't worry about it. Yes. We're not settled yet. So during the time when we're not settled, I'm not gonna hold anybody for not submitting. Okay. If you don't submit and you understand it, that's more than enough for me. But don't worry about it. You're gonna get your grade, inshallah.
ان شاء الله. ثانك يو دكتور.
يلا موفقين.
اجمعين ان شاء الله.
لا تنسونا من الدعاء يا شباب. بارك الله فيكم.
ان شاء الله يا دكتور ان شاء الله.
يلا خير، ما في داعي للاتندنس، العدد كامل. بارك الله فيكم.
شكرا، يعطيك العافيه دكتور.
جمعا ان شاء الله. السلام عليكم ورحمه الله.
السلام عليكم.
وعليكم السلام ورحمه الله. يا الله.